Okay, welcome back everyone. So this is a quick video to introduce you to the idea of friction. You're probably very familiar with it just from kind of everyday things, but what do we mean when we talk about friction from a physics point of view? Well, friction is a force that opposes relative motion between two objects. So that's kind of a good definition. Friction is a force that opposes relative motion between two objects. And the reason why I say relative motion is that a lot of the time we just tend to think that if we're moving forward, friction always points backwards on us. But here's a good example. Let's say you take a table and you take one book and a second book and you put it on top. Okay, so let's say that you give this bottom book a really good push. All right, you're careful not to hit the top book, but you just kind of push the bottom one. And assuming that you don't hit it too hard, but hard enough to get them moving, well, what happens to the top block compared to its starting location? Does it move backwards? Well, you can try this and find out that, as a matter of fact, that top block ends up moving forward. So that's just one way of saying that friction doesn't necessarily have to point backwards on an object. It always opposes the relative motion between two objects. But most of the time, to keep things simple, we usually only talk about one object moving compared to some stationary object, like a block sliding down an inclined plane. We usually talk about the plane as being kind of locked down and unable to move, and then the block is able to slide. Okay, so there's two types of friction that we can talk about. We can talk about static and kinetic. And the names are pretty self-explanatory. Static is basically friction that's enough to prevent relative motion. And kinetic is basically sliding or moving friction. Now there's a third type that is a bit beyond what we're going to talk about in this class called rolling friction, and it's kind of like a special case of static friction. And what this comes from is the fact that if you have a wheel rolling on the ground, that technically that wheel is only supposed to touch the ground at one point, and then a split second later, if it's rotating this way, a new point will be touching the ground, and then after that another point, and you get the idea. But we're not really going to worry about rolling friction. We're just going to say that we have static friction, which is to prevent relative motion, and kinetic friction, which is like sliding friction. And if you really want to understand what friction is all about, you have to get down into the microscopics of things. You have two surfaces that are kind of jagged, kind of have teeth. And so this represents two surfaces. And as they move past each other, you're going to have times when one peak of a surface will sort of catch onto a valley of another, and so on and so forth. And all of the different forces that happen between the outer electrons, the repulsive and attractive forces that occur, really have a lot to do with the macroscopic or the large scale force of friction. Okay, so what does this mean in terms of what we observe? So we usually talk about something called the coefficient of friction. I think I spelled that right. Coefficient of friction, mu. And so mu is a ratio. It's a ratio to the force of friction to the normal force. And from this we get kind of a definition of the force of friction. It's the normal force times the coefficient. And this coefficient is something that you look up in a table. And it typically relates two different objects. So you could look at the coefficient of friction of wood on steel. You could have aluminum on ice. There's an infinite number of combinations, but you just look it up in a table and it will tell you what mu is equal to. And usually mu static is greater than mu kinetic. In other words, it's harder to get something moving than to keep it moving. And another way that we sometimes write the force of friction is we say the force of friction is muffin. So mu times Fn, mufin. Get it? So anyways, there's one way to think about force of friction. There's muffin. Okay. So here's an example of how we can use the force of friction in a problem. So this is on page 97, number 137. And it basically says, okay, we got a box which has a mass of 40 kilograms and we have a coefficient of static friction of 0.69. And what we want to do is we want to find the minimum force of friction, we want to find the amount of push that we have to apply to it to get it moving. And so basically what we're trying to do is overcome static friction. So we have the force of gravity, which is equal to mg. We have the normal force, and if we wanted to move it to the right, friction would be pointing to the left. And sometimes I'll write a force of friction instead of Ff. I'll just write just a lowercase f. And if I want something to move to the right, to overcome that amount of friction, I'm going to need to have a force of push. So that's a velocity. And it's pretty easy to figure this out. We know that it's not accelerating up or down, so ay is equal to 0, or F net in the y direction is equal to 0. So the normal force minus Fg is equal to 0, and the normal force is equal to mg. So we've seen that before. And then we also know that the net force in the x direction is equal to 0. And this is kind of tricky, but basically the instant that we reach the maximum force of friction, something will start moving. And it looks kind of like this. If you think about it, if I do a graph of the applied force, or the force of pull, versus the force of friction. Or rather, let me switch that around. So the push that we put on something and the force of friction. Now, for a while, if we pull on something or push something, static friction will occur and it's not going to go anywhere. Okay? But then after some certain amount of time, so this is mu static. After a certain amount of time, we're going to switch on over to mu kinetic, and it will require a constant force to keep it moving. Okay, so back to the problem. Basically what we have is force of the push minus static friction is equal to 0. Force of the push is what we want. It's equal to static friction, and we would be stuck except for muffin. So force of the push is mu times the normal force, and we know that the normal force is equal to mg. So this is mu static, by the way. So this is 0.69, and then 40 kilograms, and then 9.8 meters per second squared. No units for the coefficient, by the way. So force of that push comes out to be about 270 newtons. Now we'll take a look at some other examples, but this is the basics for friction.